Okay, anybody have an answer for this one? Okay. Do we really even need to solve this, guys?
What?
54 divided by 3 is going to be almost 20, right? Bigger than 15? Okay. Which one does that automatically fit into? Yeah, the bottom one. You don't really even have to do any math for this. You really just kind of have to think about where the answer is going to be. Well, obviously it's going to be bigger than 5. Okay? So again, a lot of these questions aren't necessarily can you do the math? They're more so about can you think through and reason to something logically. Okay? So sometimes just taking the time to read can be really helpful in figuring these kind of things out. So this lesson is about complex numbers. We have talked about this before, but we're going to kind of review. So we want to be able to perform operations with complex numbers. We're going to use some complex conjugates. That is, I think that's new. I don't think we did that part in Algebra 2 last year. And solving quadratics with complex solutions, we did talk about that. So that hopefully looks familiar to you. Okay, so go ahead and write these down, and then we will walk through all of this. Mm-hmm.
Whoops.
Huh.
Wow, I was in the middle of talking. I was where it was.
2.
One of the peoples. For real. Check them out. You want to pull them up? I got you. Check them out.
No, I'll just email your mom and ask her to check.
I mean, I'm good. I'm chill.
Uh-huh. Okay, are we good on these? All right, first of all, let's talk about what is a complex number. A complex number is in the form of a plus bi. So we're talking about our imaginaries here, okay? So a is the real part, b is the imaginary part. So it might be something like 4 plus 3i. Okay, that's a complex. 2 minus 7i. 9 plus 16i, whatever. They are not like terms and cannot be combined. Kind of how an x works. It's the same idea. We can, first of all, solve. So for example, if we know that a complex number is equal to a complex number, we know that the real part is equal to the real part, and the imaginary part is equal to the imaginary part. So we could say that xi is equal to negative 9i. Therefore, x is what? Don't all answer at once. If xi is equal to negative 9i, what is x? Negative 9. Which means that we know that 2y is going to be equal to what? What's the real part? 6, yeah. Meaning y is 3. So first of all, we can use complex numbers to help us solve things. The real part has to equal the real part. The complex part has to equal the complex part. Okay, we can also add and subtract them. It's the same idea. Combine like terms. So combine the real parts, combine the imaginary parts. So if we take 9 plus 2i minus 6 plus 7i, we're going to take 9 minus 6 and 2i minus 7i. Done. This looks familiar, right? Or at least understandable. Okay. Go ahead and try that next one. See what you get. Okay, do you agree with me? Is my math right? Okay. So be careful with this minus out front because that makes this a plus 3. So 3 plus 2 is 5. And then 4i minus negative 5i is 9i. Minus 6i is 3i. Okay? Multiplying. We're going to multiply this out and then combine like terms. Now, I really strongly suggest you use the box when doing this. Here's why. So when you multiply 9 plus 2i times 6 plus 7i, we're going to multiply out all the pieces. Does anybody remember what I squared is equal to? Negative 1, which means that this is negative 14. The reason I like the box is because it helps you then combine like terms. So 54 plus negative 14 is 40. And 63i plus 12i is 75i. Yes. I squared equals negative 1, which we then multiply by the 14 that's already there, which gives us negative 14. Now, here's the thing with the box. You're just changing the sign of the coefficient is really what you're doing. Okay, so let's try the next one. 3 plus 2i times 3 minus 2i. Go ahead and multiply that out. See what you get. Okay, tell me if I did it right. Are you sure there's no i's here? Yeah, because the positive 6i and the negative 6i cancel each other out, right? So then we have 9 plus 4, because negative 4i squared is positive 4, which gives us 13. Are we going to get 13 for the next one? Why not? Right, because they're going to be both plus 2i's. This first one was one of each. So we're going to square the 3 plus 2i. So when we combine our like terms, that 9 minus 4 this time is a 5 plus 12i. Okay? Are we remembering all of this, the adding and subtracting and the multiplying? Are we okay with it? Any questions? Okay. The conjugate. Okay? Complex conjugates are pairs of complex numbers that when multiplied together result in a real number. I'm going to flip back really quick. These are conjugates. 3 plus 2i and 3 minus 2i are conjugates. Because when you multiplied them together, we got just 13. What do you notice about those two things? 3 plus 2i and 3 minus 2i. What do you notice about that? Okay, they're exactly the same except for the sign. That is what a conjugate is. So the conjugate of 4 minus 3i would be what? Exactly the same, but different signs. So 4 plus 3i. Conjugate is a word that you need to know. Radicals have conjugates, which we will talk about more. Complex numbers have conjugates, and they work effectively the same way. I don't want to say they're exactly the same because they're not, but basically, the idea, the concept is very much the same. Because we're going to get a real number. We can multiply by the conjugate to get rid of the complex part. Kylie, what'd you get? Kaden, do you agree with her answer? Multiplying 4 minus 3i and 4 plus 3i. Okay. Rocio, do you agree? Yeah, good job. Yep. So if you multiply it all out, the middle terms cancel, and they should. That's the whole idea. We're trying to get rid of those I terms, those complex terms, and we end up with 16 and then negative 9i squared, which is plus 9. 16 plus 9 is 25. Good job. We use complex conjugates to rationalize the denominator. So the rule in math, I guess this is kind of a general math rule, if you will. You cannot have an imaginary number in the denominator of a fraction. Yes, or you should at least know this. So we are going to multiply both the top and the bottom by the complex conjugate of the denominator so that that I goes away. Now the reason behind that, remember we talked about complex roots and how the graph doesn't touch the x-axis? When we have a complex denominator, things get real crazy and become undefined and it's ugly. So if we can keep those complex, those i's out of the denominator, that helps us when we're trying to graph things or figure things out. So I don't know that you have to copy this whole thing down, but at least the idea of it, so you know like what we're doing, okay? You good? You're still going? That's fine. I just can't see over your backpack. Okay. So what is the conjugate of the denominator? So we're going to multiply both top and bottom by that conjugate. What allows us to do that? What is 4 plus 2i over 4 plus 2i? 1. And we can multiply 1 by anything because it doesn't change, right? So with a fraction, as long as we multiply the top and bottom by the same thing, we're creating an equivalent fraction. Okay? But the nice thing is when we do the denominator, we're going to get rid of that complex. So here's my little tip, if you will. Multiply the first two. Multiply the last two. And then change the sign. So this is negative 4i squared, so plus 4. Okay, you do not have to multiply that all out. It's the conjugate. We know the middle terms are going to cancel. Save yourself some time and energy. Now, the top you do have to multiply out because the terms aren't going to cancel there. So we're going to have to multiply that whole thing out. And then, of course, combine your like terms. And you're welcome to use the box. I would, again, with squaring things and such, I would like us to get to the point where we can kind of do this mentally. But I understand if we're not there yet, and that's totally okay. Okay. So my math is good. Can we simplify this? Yeah, we could reduce all three of those numbers by 2. And we should. It becomes minus 6. So if you can simplify or reduce that fraction, you should do that. We always want to write our answers in simplest terms. That's the final answer. All right, try the next one. Multiply by the conjugate of the denominator. Change that to yes. Yep. Good job. Andy, do you have an answer?
No.
Are you sure?
Yeah.
Okay. Do you have an answer? How do you know that?
My instinct system. You see.
I bet you your instincts are that great. Thank you. Okay, so when we multiply on the bottom, we end up with 4 plus 1, which gives us that 5, right? And on the top, when we multiply it out, we end up with 4 minus 1. And then 2i plus 2i is 4i. Good job, thank you. Are we feeling comfortable with this? Can we figure out what the conjugate is? So same thing, but change the sign. Can we multiply by the conjugate? And then can we simplify? We do this to help us solve quadratics. So when we're solving a quadratic and the radical is negative, we have to include an I in our answer. And that's where those complex numbers come in. That also means that we are probably using the quadratic formula. Why would I not factor this? For example, why can't I factor it that way? -5 plus 3 is -2. So why can't I just factor this? There's something wrong here. I did something incorrect. What is it? That makes this not factorable.
Oh.
Yeah, because it's +5, right? So my terms have to add up. The signs have to be the same. And then that, of course, does not give me a -2. So this is not factorable. Do you guys remember how to check and see if it's factorable? Do you remember the discriminant? B squared minus 4AC. So if we take B squared, so -2 squared minus 4 times 3 times 5 is 4 minus 60, right? Feel free to check my math on that. In order for it to be factorable, first of all, that would have to be positive. And second of all, it would have to be a square number, like 16 or 25 or 81, etc. Since -56 is neither of those things, we know it is not factorable. Now, here's why I suggest checking the discriminant. Because you've already done half of the work of the quadratic formula, right? We just found what's in the radical. Now we just have to fill in the rest of it. So it doesn't hurt anything to check the discriminant and see if it's factorable, because you're already halfway through the quadratic formula when you do that. So -b, +2, plus or minus the square root of -56 over 2 times 3, which is 6. Now, I know I'm going to have to simplify that radical with an I. But we've talked about sometimes we simplify the 56 and sometimes we don't. Here's how I know. Okay? Do 2 and 6 have any common factors? Yes. Therefore, I need to simplify the radical and see if it also has a 2 that can be factored out. So if this were 2 over 5, I wouldn't bother because 2 and 5 have no common factors. But because 2 and 6 do, I'm going to need to simplify radical 56. So I'm going to make a factor tree. And of course, I have a pair of 2's. Remember, we multiply what's left. So 7 times 2 is 14. And then the point of doing this is that we can then factor 2 out of everything. And there's our simplified answer. How do you feel about this? Okay, the simplifying part? Okay. That's fair. So, do you see how I jumped from the discriminant to filling in the quadratic formula? Okay, that is where we get the discriminant from. It is from the quadratic formula. So once we find it, we can just plug that in. Okay, if it was positive, in order to be factorable, it would also have to be a perfect square. So it'd have to be 16 or 81 or 4. If it wasn't, then it's still not factorable. It just doesn't have an I. The negative means there's an I. The perfect square means that it's factorable. Yeah, then you can still do the quadratic formula. Because the whole point is to solve it. Remember, this is what x equals. That's the whole point, is that we're solving. Let's try another one. What do you think is the first step here? Before that. Yeah, let's multiply by a common denominator and get rid of the fractions. That's going to make anything else we have to do much easier, okay? What is the common denominator? 16. Do you agree with what I did? So when I multiply by 16, 16 divided by 8 is 2. 2 times 7 is 14. 16 divided by 4 is 4. Times 3 is 12. And the 16 divided by 16 is 1. Times 5 is 5. Everybody with me on that? So for the first fraction, 16 divided by 8 is 2. So I multiply 2 by 7. If it makes it easier, just pull out your calculator and multiply 16 times 7/8. Why am I dividing? Because when I multiply by a fraction, I'm doing this, right? And they cancel? If you pull out your calculator and multiply 7/8 by 16, you'll get 14. Is that how you did it? How did you do it? Oh, okay. So now that you see it, does it make sense? Are you sure? Okay. Okay, let's move on. From here, remember we talked about solving quadratics. Anytime that first number, that leading coefficient, is bigger than like 5, we probably don't even want to factor. We just want to plug it into the quadratic formula. So I would not bother with the discriminant here. I would just put it into the quadratic formula. Okay? So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Now, let me be clear with you. I am showing you how to plug everything in, okay? If I were doing this problem on your homework or when I'm making an answer key for a test, I would not show all this work. So I do not expect you to either. If you can simplify as you go and put it in quicker, I'm fine with that, okay? You do not need to show this much work if you don't want to. It's your choice. I'm just doing it to show you where everything's going, okay? So then we start by simplifying in the radical. And we have 144 minus 280, right? Was that a yes? Okay, thanks. Please always check my mental math. Sometimes it's more mental than math. And 144 minus 280 would be what, negative 134? No, 136. Yes, no, maybe? Guys, please make sure I'm not just making up random numbers here. Don't just write it down and assume that I'm doing it in my head correctly, okay? Please always check me. So then my question is, do I need to simplify the radical? Do 12 and 28 have something in common? Yes. So I need to simplify that radical. So I'm going to simplify 136. 4 times 34. So I have a pair of 2's. Yeah, don't forget about that I, by the way, because it was negative. So we do have to have 2I out front, not just 2. And then, of course, I can cancel a 2 from all of these, leaving me with 6 plus or minus I square root of 34 all over 14. That is simplified. Our final answer. We are done. Wonderful stuff, right? Hopefully it's mostly review. We did do all of this last year. The fractions are a little more complicated, but we did all of the quadratic formula and the i's and everything. So hopefully you're not feeling like it's completely brand new. The one new part is the conjugate. Come on. So can we rationalize? Can we find the conjugate? Can we multiply by the conjugate? Can we simplify? That's the big takeaway from this, okay?